Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw shear force and bending moment diagram of a cantilever beam having UDL on its entire length. As you can see in a diagram, we have a cantilever beam, so we have only one fixed end, the other end is free. So that's called cantilever beam. We have three steps to follow: reactions, shear force diagram and bending moment diagram. Okay, first of all, what we will do, we will calculate reactions. Okay, to calculate reactions, we have to calculate the load. Okay, so what is total load? So reaction would be RA is equal to total load. So this is some kind of formula. Okay, so total load we have 4 kilonewton per meter. We have 2 meters. 4 multiplied by 2 is equal to 8 kilonewton. So the total load acting on this beam is 8 kilonewton. Now based on this number, we can draw our shear force diagram. Okay, how we can draw our shear force diagram? As you can see, so this is going to be it's 8 kilonewton. Okay, so 8 kilonewtons is acting upwards, trying to support our beam. Okay, so let's say 8 kilonewton is here somewhere. We'll draw a line. So this is 8 kilonewton in positive zone. Now we have to see, in order to get to point B, so this is our point B and this is our point A. Okay, in order to get to point B, we have a UDL load which is uniformly distributed over the length of a beam. Okay, so how much is it? It's 8 kilonewtons, right? Because we are going to point B and we have a UDL to cross, so the UDL is influencing our beam on its entire length. So what it will do, at point B we have nothing, for example we have no reactions, so all the reactions only point A is bearing. The diagram would become something like that. We will just connect our line with point B. So that is our point B and this is our point A. That's how you can draw a bending moment diagram for this type of beam. Okay, now we have to calculate we can draw shear force diagram for this type of beam. Now we have to calculate bending moment. Okay, so bending moment at point A. So at point A we have 8 kilonewton acting upwards, so 8 multiplied by 0, so it will be 0. At point start we always have 0. Okay, bending moment at point B, so we only have 2 points, A and B. In the middle we don't have, but if we like we can create another point in the middle and the calculation at the end will be the same. So I'm not going to create any other additional point in the beam, so I will only calculate this beam with only 2 points. Okay, so 8 multiplied by 2, because to get to point B is 2 meters, so then we have minus. Now this is a point load. You can say that it's a point load because it's going upward. Now we have a UDL which is 4 multiplied by 2. This is 4 multiplied by 2. This is a load multiplied by 1, because 1 meter UDL always acts its half length. So it will be 16 minus 8. Okay, so we will get 8 kilonewton. Now because this is a cantilever beam, we don't have any other supports, so that's why we don't get 0 at the end. Now based on these two numbers, we will draw our bending moment diagram. So how we can draw that? At point A we have 0, at point B we have 8 which is positive, so 8 will go somewhere here. Okay, so that's our 8 kilonewton. Okay, to draw a bending moment diagram, we will use a parabolic line. So the parabolic lines will be something like this. So it's not a diagonal line, it's a parabolic line. Okay, so that's how we can draw our bending moment diagram for this cantilever beam. I hope you have understood what I have explained. If you still don't understand, don't forget to write in your comment box and I will try to explain it again. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.